Hello guys. So for today, a very quick and short video will not actually waste a lot of your time. I actually wanted to discuss about CAP theorem. Okay, in distributed systems, it's very common to you might have to choose the one. It's like the red and the blue pill from the matrix. So let's just deep dive into it. I think that would be much better rather than me making weird gestures. So in case of what is CAP theorem? So CAP theorem says that we have three things. C for consistency. Consistency means that if Ahmed, for instance, sitting in USA, makes a change to the data, that data is readily replicated to Pakistan server, and Ali would start seeing it readily, quickly. It won't take a long. Okay. Either they both will see the same value at the same time or as quick as possible, or they will not see the same value. Okay. So that is what it's consistency. Let me come to the next point, which is availability. After beside consistency, we have availability. So if the server goes down, for example, if the replication server goes down and now the USA server and Pakistani server are not connected anymore, what will happen that should we stop showing data to the users, both Ahmed and Ali? If, for example, Ali makes a change or and Ahmed tries to read it from the USA server, of course, he is not going to see it because of the broken replication logic. Here, instead of not showing anything at all, we would like to actually show something, okay, even the stale information. That is what we call as availability. While P stands for partition tolerance. For example, if something breaks, as just I gave an example here that the replication logic breaks, two servers are not in sync anymore because it's a distributed system. These both are nodes. Consider them as nodes. So the CAP theorem says that you will always have to choose between the two, consistency or availability. You cannot choose the both. And in doing so, partition tolerance will always be there. Your system should be tolerant to network failures, any kind of other faults and problems. So if your system, for example, if one node goes down and the entire system collapses, then but you do need to make sure that you are working in software engineering and not getting fired soon. So that is what CAP theorem is. I already explained the example, and let's just try to understand simple examples about CAP theorem. For example, if you have a social media, if the user, let's just say Ali and Ahmed, Ali updates his profile picture, and if you want a strongly consistent system in this case, I do not think it's needed. But eventually, Ahmed will see the updated profile, not just quickly, as soon as just like I click profile update and boom, its update reaches Ahmed servers or Ahmed data. It's not needed. Okay. And the second thing is the second example in case of financial transactions, and that is something worth hard attack. Let's just consider a scenario that you try to send money from Ahmed's account. Ahmed tries to send $500 to Ali, and the money goes out from Ahmed's account but never reaches Ali's account. Just imagine this scenario. How would you react to it? If you want an available system, it is available. It will eventually show up, but you will get a heart attack meanwhile. Otherwise, you would like to say that I cannot wait on it. It should be strongly consistent. I should get the value right now. Otherwise, I'm going to sue the bank. So that is where the consistent systems are in place. We have to make sure that they're strongly consistent. One more better example, I think, would be the ticketing booking system. For example, two people are trying to book the last ticket on a movie, and both of them book the same ticket. And on the day of the movie, they reach the cinema, and now they have to either fight for the seat or there is no other way. Now they're going to sue the company. So that is why CAP theorem exists in distributed systems. Okay, I hope you understood it and learned something new. That was actually a quick video for today. Have a good day. Bye.